Okay, let's dive right into this explainer. Today, we're going down a truly fascinating rabbit hole of Go dependency management. We are going to explore a recent structural change in Go that, honestly, at first glance, might actually have you questioning your own sanity, or at least your environment configuration. We're looking at the Go 1.26 release and a very deliberate, kind of mysterious default behavior that has caught quite a few developers off guard lately. If you write in Go, you absolutely need to understand how this mechanism works.
To really understand the mystery here, let's start where literally every new project begins. Imagine you're bootstrapping a brand new directory. You pop open your terminal, you run your standard mkdir, and you step right into it. Just to be absolutely certain you're working with the latest and greatest, you run go version. The terminal proudly prints back go version go 1.26.0. Perfect, right? Everything is up to date locally. Then you execute go.mod init to initialize your dependencies. The tool creates your module file, just like it's done 1,000 times before. Everything seems completely normal. But then, you actually open up that newly created file, you scan the contents, and you have to stop and ask yourself, wait, what's wrong with this picture? There is a really distinct discrepancy staring right back at you.
Here's the mystery laid bare. Your local machine, your actual executable binary, is undeniably running Go version 1.26.0, but the module declaration inside that freshly initialized file, it defaults to an older version, specifically Go 1.25.0. It almost feels like a bug, doesn't it? Why would the absolute latest toolchain initialize a project telling the system it's built for the previous version?
Naturally, the very first instinct of literally any seasoned developer is to blame their own local setup. I mean, we've all been there, some rogue environment variable left over from a project 3 years ago quietly ruining your day. So, to make sure local configurers aren't playing tricks on us, we check the environment variables. But looking closely at the root, the tool directory, and the version, they all consistently point to version 1.26. It's indeed running everywhere on the system. There is no hidden 1.25 binary intercepting our commands.
And just to be completely exhaustive, searching our entire Go environment setup for any trace of version 1.25 comes up completely empty. You run a grep for 1.25 and it returns absolutely nothing. Zilch. Nada. So this completely rules out our false leads. The system isn't confused at all, it is doing this entirely on purpose.
Well, the investigation leads us straight to a highly deliberate design choice introduced in Go 1.26, the N-1 default. The Go development team actually implemented a new rule where new modules now explicitly target the previous major release. Because you are running 1.26, which is our N here, the initialization automatically defaults your module to 1.25, or N-1.
And honestly, this brilliantly illustrates the Go team's official policy. They officially support the two most recent major releases. By defaulting to that N-1 version, they're essentially enforcing broad compatibility right out of the gate. When you publish this new module, anyone running Go 1.25 or Go 1.26 can easily consume your code without hitting immediate versioning conflicts. You are automatically being a good citizen in the open source ecosystem without even trying.
So here is the crucial mental shift we need to make. That Go directive in your module file, the line that says Go 1.25.0, isn't a reflection of your local hardware setup. It's a strict compatibility contract. It's telling the entire ecosystem, hey, this codebase only uses language features and standard libraries that existed as of Go 1.25. It guarantees that an older compiler won't just choke on some brand new syntax that was released yesterday.
But wait, what if the Go 1.26 compiler has some amazing new performance optimizations or critical bug fixes that you really want to utilize when building your app? Well, that is exactly where the toolchain directive comes in. While the Go directive is your compatibility contract, the toolchain directive acts as the actual machinery. It dictates the specific compiler used to build the project. And incredibly, if you specify a toolchain you don't actually have installed locally, Go just handles the automatic downloads to make it happen, auto-magically. So if you want the absolute best of both worlds, you can explicitly add this machinery to your project. By running a super simple command line edit, just passing the toolchain flag, you are modifying your module file to give explicit instructions to the build process. You don't have to guess, and you don't even have to manually edit text files. The Go CLI handles this cleanly for you.
Now, what's really interesting here is seeing how these two directives sit perfectly side by side in your final file to balance safety and speed.
Notice how you have the 1.25 version ensuring backward compatibility so the wider community can actually use your package. And then, right below it, you have your 1.26 toolchain, ensuring that when the code is compiled, it gets all the latest performance improvements and bug fixes. It's just an incredibly elegant separation of concerns.
And of course, Go isn't just locking you into the past against your will. If you ever actually need to use the absolute latest language features, say a brand new syntax edition that literally only exists in 1.26, you always retain the power to explicitly update that compatibility contract yourself. You simply run a quick edit command and boom, your module is now strictly a 1.26 project. The choice is entirely in your hands, but the default gently pushes you toward ecosystem stability.
Let's zoom out for a second, because this matters immensely for the overall health of software development. By building this logic directly into the language's native tooling, Go avoids the massive downstream issues that plague so many other ecosystems. I mean, we've all dealt with broken builds just because a teammate had a slightly different local setup, right? Or because a dependency silently demanded a compiler feature no one else had installed. Go prevents all of this by separating language compatibility from compiler execution and by natively downloading the exact required toolchain automatically. You pull down a repo, you run build, and it just works, exactly as the author intended.
Which leaves us with a truly fascinating thought to consider as we wrap up this explainer today. We are currently living through an era of rampaging software supply chain attacks, which are so often born from messy, unverified, or easily spoofed dependency chains. When a language like Go so rigorously controls its toolchains, automates the correct environments natively, and tightly manages compatibility contracts right down to that N-1 default, could this kind of structural language foresight be the ultimate blueprint for ending macro-level supply chain vulnerabilities? It's a seriously powerful approach to dependency management and definitely something to think about the next time you initialize a project.